So we've already talked about horizontal resisted motion and how that kind of comes about, right? Like friction, you know, and what other kind of things? No, so we don't consider any vertical things. So we don't consider gravity when we look at the horizontally resisted motion. So typically it's like the friction that applies there. So yeah. Yeah, I'm not too sure. I suppose it's like, regardless of what the air resistance is, we know how to sort of deal with it now, right? So the same thing is kind of going to apply with vertically resisted motion. And you're going to see equations like these again. I equals to minus kv or minus kv squared. So it's inversely proportional or inversely proportional to the square of the velocity. And same thing again, right? We know that the resistance experienced by an object is proportional to its velocity, right? Now the question is, in terms of the resistance experienced, where does mass kind of come in? What's the role of mass and of an object when it's falling? Have you guys kind of talked about that in physics? Like, how does the mass of an object affect sort of its gravity? Right. And how does it affect as an object is falling, for example? Because we're talking about vertically resisted motion, and you can talk about objects rising or falling. But so suppose we had two objects of a different mass, right?
According to Wikipedia, Singapore, officially the Republic of Singapore, is a sovereign island.
We don't worry about Singapore. How does an object's mass sort of affect how it may fall? Is the question.
I'm pretty sure the mass is like proportional directly proportional to the force. Like the greater the mass, the greater the force. So it'd be like of like gravity. Is that what you mean? Or like,
have you guys talked about? Yeah. Well, thoughts on that?
like F is what.
Yeah. Thoughts on that? If I have two objects of different masses, I don't know, like clipboard and merits, right? Well, in terms of how it falls, like, does the mass of an object affect, like, how fast it falls, for example? No?
They all fall at the same speed.
There's a thought experiment by Galileo, right? I don't know if you've heard of this one, like the Leaning Tower of Pisa. Have you seen this before? So the thought experiment is that he has like a bowling ball in one hand or like some other smaller object in another hand, and he drops them off the tower at the same time, right? And I think Aristotle at the time used to believe that the heavier something was, the faster it would fall, right? But then the idea is that the I guess terminal velocity is not affected by the mass of a particular object, right? So that's one thing that we look at, the terminal velocity. And there's a video that shows this really well. So if you look at this guy over here. Yeah, so he is on the moon, I think.
Wouldn't the speed depend on like the surface area?
So yeah, I think he drops a feather and a hammer at the same time, and then they fall at the same rate, right? Yeah, a feather. So I guess there's no air resistance out there, hey. So usually there would be air resistance, and that would affect things, obviously. But he's on the moon, right? So yeah, the Aristotelian theory of gravity is like objects fall at a speed relative to their mass, which we know is not true from an experiment like this, right? And there's all other kind of free fall things that we have looked at. So one thing that we'll look at is this idea of terminal velocity, right? So the speed which an object reaches at some point. And we have a mathematical way to describe this. So if we look at something like this, the terminal velocity, when does that occur?
When?
Yep. How do we like reach terminal velocity? So it's like when our speed isn't increasing anymore, right? If our speed's not increasing anymore, what does that mean our acceleration is? Because if acceleration is the rate at which our velocity is changing, yeah, exactly right. Our acceleration has to be 0. So the terminal velocity, we usually call it v sub t, occurs when a is equal to 0 as t approaches to infinity.
It's terminal velocity because it's like at a certain speed.
Yep.
The air resistance is like making so you don't accelerate.
Well, I think that's a really good way of understanding it. And to say that again, it's when
when air resistance like slows you down.
Right, that is equal to the
Force.
equal to the acceleration of gravity. Is that what you were saying? Yeah. So I think you can think about it like diagrammatically as well, right? So for example, if you have an object that's falling, so a falling object, for example, if we think about what this will look like, we've got our object going in this particular direction, and we have the air resistance experienced as well, or whatever resistance that we're looking at. And so initially, we have our mass and gravity, and we've got the resistance that's being experienced, right? So obviously, if this is less than this value here, then we're going to continue accelerating, right? We're going to continue getting faster. But as you said, if at some point these are equal to each other, and then this is acceleration, if they're equal to each other, if r is equal to mg, I guess you could say that we experience our terminal velocity, right? And maybe at some point, maybe r could even be greater, like if you had like a parachute or something and it blows up, then you start slowing down, right? So I think diagrams are going to be a key thing here when you're doing this. So always draw diagrams, right? Just make a note of that somewhere. Because the forces diagrams are going to be very helpful understanding the situation. Let's sort of think about the falling object from a mathematical perspective though. And we know that if I have a falling object, in terms of a mathematical perspective, our downwards motion is positive. And we're going to have two forces as well. We've still got the gravity and air resistance, or whatever resistance. So we've got two forces, gravity and resistance. In this case, when you think about, and this is why I want you to draw the diagram, because when you think about the direction of travel, if I have this object here, so this is the direction of travel, the resistance is now going up, right? But what's happening with my gravity effect? Well, it's actually going to be contributing to the direction of travel, right? So this is actually a positive value, where this is going to be, like a negative value. Does that make sense? Right? Because it's going in the same direction as the direction of travel, then we consider this to be positive, and we consider this to be negative, right? So resistance goes to you. Is that fair? That's why you want to draw the diagram, because the equation is going to be slightly different. The equation, if you think about your F equals to ma, is going to be something like this. So we've got our mass and acceleration here. But the forces now, if for example I had minus kV, then I'm going to have minus kV plus mg. So the signs there are going to be different depending on what you have. As opposed to if we had a rising object, our upwards motion is positive. We still have the two forces in the rising object, right? But now the direction of travel is different, right? So the direction of travel is going up. And now we have kind of two forces acting on this. We've got this, I guess, right? We've got the mg, and we've got kV as well. We've got the resistance. So they're going in the same direction now, in this case, yeah. So if we take F equals ma in the same way, then so these should be like negative, right? Because it's going in the other direction. So then we have our forces minus mg plus kV is equal to the mass times acceleration, or you could just say minus mg minus kV. So I just want to double check this one's right. So they're kind of saying the resistance is like, no, it should be negative, I'm pretty sure.
Yeah, it should probably always be negative. It's always going to come in the other direction.
Yep. Whereas the mass in this one is positive because it's going in the same direction. So I think that's okay. I might have just made a typo myself. Sorry.
That makes sense.
Cool.